Hello, let's look at the logistic differential equation in Calculus BC. Let's break it down. Let's look at the anatomy of it. It is two terms multiplying. The two terms refer to two opposite force, the growth and the break. So for the first growth item, the KP portion represents the pure exponential growth. If resources were unlimited, the growth rate would depend entirely how many people already exists. More people means faster growth. And then for the second item, the break, this portion represents the environmental break, or the room left to grow. As the population gets larger, foods or resources would run out. Let's say for the P item, when P increase, and then L minus P would decrease. If KP decrease, and then L minus P would increase. When you multiply them together, you get a dynamic system. It balances the growth and the break. In AP Calculus BC, you will see the logistic differential equation written in two different ways. So for the form A is the remaining population form. Population change with respect to time equal to a constant multiplied by the population and the remaining population. We would also see another form if we take the L side of the parentheses. We get dp change with respect to the time equal to KLP L minus. So this is the percentage form. And then KL here would be considered as a new constant as an R. Now let's look at these two most critical features of the logistic curve. First is the carrying capacity. The carrying capacity L is the absolute ceiling of our model. At time t approach infinity, the population P would approach L. And then is the max growth rate. The max growth rate happens at P equal to half of the capacity. Actually, this is almost a guaranteed AP question. It will ask you when is the population growing the fastest. The answer is always exactly when the population reaches half of its carrying capacity. Why? If you look at this equation, the right side is a downward facing parabola with respect to y. The root is at 0 and the vertex, which the absolute max rate just sits exactly in the middle of L divided by 2. On the population graph, this is your inflection point, where the curve stops accelerating upwards and starts leaving off. Now let's apply everything we just learned so far, then solve this classic multiple choice question. So we have a community of 6,000 people. The problem states that all people in the community eventually become informed. This is a massive clue. It tells us that our absolute ceiling, or our carrying capacity L, is 6,000 people. We are also giving a specific snapshot in the time. When P dp over dt is equal to 100. These are written in the standard percentage form, that we have the dp by dt equal to the first growth item and then the next break item. Since we already established that our carrying capacity L is 6,000, we plug it back, and then the denominator inside of the parentheses must be 6,000. Actually, it's pretty obvious that we can choose out D as our answer. But let's go thorough and prove that's constant. So we take the standard equation, we plug in dp dt equal to 100 when the population is 1,000. Now we solve for R, and then our R equal to 0.12.